being able to model, so we understood actually where these rules are going to be coming from, we were able to notice patterns, right, when we were multiplying, and we were able to create what we call integer rules. Okay? That'll apply to any time we multiply two integers together. It'll tell us whether our answer is going to be positive or negative, right? So we talked about, well, a positive times a positive is going to be positive. We said a positive times a negative is going to be negative. A negative times a positive is going to be negative. Okay, and then finally, a negative times a negative is going to be positive. So if you think of examples that we did in class together, okay, or from our previous video, I'll use that example. All right, 3 times 5, well, that's going to be positive 15. That's usually what we're used to seeing. Okay, two positive numbers give you a positive result. Okay, but let's say I have positive 3 times negative 5. Okay, well, we said, okay, that means that there's 3 groups of negative 5s. Okay, 3 groups of negative 5, that's going to give me negative 15. Right, and then the one below that, okay, if it's negative 3 times positive 5, okay, we always want to put brackets around our negatives as a good habit. Negative 3 times positive 5, okay, well, that means the same thing. Okay, these two are equal. Okay, they mean the exact same thing. We can always reverse them. Okay, I could have changed this, right, and said that this was negative 5 times positive 3. Okay, they mean the exact same thing. It'll always be the same value. Okay, so we know multiplication can be switched around. Okay, the numbers can be switched around. Okay, the sign can be switched around. Okay, it's just a pattern that we have. So let's say this was negative 3 times positive 5. Negative 3 times positive 5 means I'm taking away 3 groups of the positive 5s. Okay, so if I start with 0, okay, we started with the 0 pairs on our board, and I take away 3 groups of the positive 5s, I take away the positive 5s away, then I'm going to be left with 15 of the negative chips. Okay, and then finally, we were able to prove that negative 3 times negative 5. Right, well, we said once we create those 0 pairs and I take away 3 groups of negative 5s, well, I'm left with the positive 15. Okay, so using these rules that we created above, we're able to do questions. So let's say I have negative 4 times 3. Okay, well, we look at these numbers, negative 4 times 3. Okay, first I ignore the sign, okay, and I pretend I hide them. Right, so let's say I hide it. Okay, and let's make them. There we go. Okay, so we're going to hide the sign there first. Okay, so all of this is 4 times 3. Okay, well, 4 times 3, that's going to be 12. Okay, we know that basic multiplication. And then from there, I'm going to hide that middle part here. Okay, that 4 times 4, the times 3. Okay, and I look at what's my sign. Okay, well, I have a negative here, so it's going to be a negative times, and then the 3 is positive. So a negative times a positive, we go up to our top. And we look, negative times a positive is negative. So the answer would be negative. So it would be a negative 12. Right? If we were to do another example, where we have 3 times negative 7, for example. Okay, first we look at 3 times 7. Okay, and that gives us 21. After we have that number, then we look at the integers. We go, okay, well, 3 is positive, and the positive times the negative is going to be negative, so we know that it's got to be negative 21, and that's how we're able to solve questions of this type.